It's high noon. Welcome to KTAL LP FM in Las Cruces, New Mexico. You're listening to a segment, Science. Let's take a look. I'm your host, Vince Gucic. I'm here every Tuesday noon until 1. And I'd like to take a moment to thank the people who responded to our membership drive. We had 82 KTAL listeners become founding members, including 20 members of the Century Club who gave us $101.50, obviously our call number. And we have 5 monthly sustainers. So this is truly your community radio station, and we thank you. We had aimed at 100 new members. We're still 18 members short. Of course, we'll take any number that would like to donate. So you can go to the website or Facebook. The website is, well, there's two. Radio KTAL, QUETAL.org, and there's also lccommunityradio.org. On both sites, there's a donate button, and we hope you'll visit us there. Thank you for your support, and keep listening. I am the host, and I'm also the chair of the board for the Las Cruces Academy, a private school here in Las Cruces. The LCA has become a Century Club member today, so we're in for the long haul. So let me tell you a bit about community radio, just a short bit. We are basically volunteers keeping the thing going. Some people put in a lot of time and money to set up the studio, which is glorious in a word. So we're bringing everything local to you, as well as streaming other local radio stations from around the country. You can also stream this show live at either of those sites that I mentioned. Okay, so I am going to do basically monologues today, although next week, January 23rd, my guest will be Professor Kathy Hanley from the biology department at NMSU, who will have fascinating and scary things to say about the emerging viral diseases, Zika, dengue, chikungunya. She's an internationally known researcher, and I'm sure you'll find her interesting. Today, I'm going to start off with a segment, well, it's going to cover several, called Have You Thanked a Bacterium Today? Seems maybe an odd thing to do, but think about it. Okay, right now in your intestines, common bacteria such as E. coli, Escherichia coli, are working down there to make vitamin K in the form vitamin K2. You need that for proper blood clotting, and it also helps with your calcium metabolism all throughout your body. And that's a special help for you if, like many Americans, you don't eat leafy green vegetables or other rich sources of the vitamins, or if you have to take broad-spectrum antibiotics, such as doxycycline, well, that knocks out those bacteria, unfortunately, or if you have chronic kidney disease, then the bacteria in your intestine are working for you. I note that I took doxycycline recently as an anti-malarial when my wife and I went to Vietnam and Cambodia. It was with some trepidation for its side effects, namely killing off intestinal bacteria. I couldn't take Malarone because it makes me very ill. And then it was disappointing because we never saw any significant mosquitoes. I think we saw 6 on the whole trip. Oh well. Anyway, vitamin K appears to benefit only some humans, all humans, and some other animals as, it also benefits the bacteria in the sense that it makes us willing symbionts for them. Vitamin K is a pretty simple organic molecule. There's a core part to it called 2-methyl-1,4-naphthoquinone. And if you're a chemist or have other chemical background, you can look that up And there are different forms of the vitamin with different side chains added. So, some other things that bacteria do for you, well, your brains, and for many of our fellow species, basically anything that has a nervous system. So we'll skip sponges. Only bacteria synthesize cyanocobalamin, also known as vitamin B12, and that keeps our nerves functioning. Plants can't make it, animals can't make it, fungi can't make it. So ultimately, bacteria keep all of us alive. Now, B12 deficiencies are pretty rare. Grazing animals have bacteria in their guts to make B12. They're resident. But they can become deficient if they're grazing on forage grown in soils that are deficient in the metallic chemical element cobalt. And here I think of poor Australia, which hasn't had surface renewal by basically continent building for, who knows, up to 3.5 billion years in some places, and not much volcanism. So the cobalt doesn't recycle very well there. Now, most Americans are going to get their B12 from eating animal products. Plants aren't so good at taking up B12 and putting it in their tissue, so it's really animal products. Of course, one consequence is that vegans have a challenge getting enough B12. Other than taking a supplement, the way to do it is probably eating some food with bacterial contamination. That's not too hard. Okay. The bacteria themselves use cyanocobalamin as its cofactor or a helper with some of their critical enzymatic reactions. So they're not doing this altruistically. That's not a common thing in nature. Now, an interesting thing about lagomorphs, rabbits, so on, they get their B12 in a way that is a little surprising. They have to eat some of their own feces. The bacteria in their intestines make the vitamin, but the rabbits can't absorb it there. They can only absorb it in their upper digestive tract. They don't seem to mind this, and I guess we're lucky we're not rabbits. Now, you can overdo it. Excesses of vitamin B12 are very rare and occur only in people taking massive supplements. It causes nerve damage in excess, and over time, it becomes irreversible. Basically, everything is toxic in the right amount. Okay, so that's a quick summary of some things that bacteria are doing for us every day. Now, another part we might say is, let's thank bacteria for their eons of service. All right, we are mobile organisms. We're very active. We think, and our metabolic rates show all of this. The secret is that we have an aerobic metabolism. We use oxygen as a reactant with glucose and breakdown products to generate whole rafts of energy, and that's compared to organisms that just break down glucose without oxygen, or some that use energy sources that look pretty obscure to us and often are poisonous to us. I'm thinking of hydrogen sulfide or abundant ferrous iron. So I'll talk a little bit more about oxygen in our metabolism, but let me make a note about one of the sources I mentioned for other organisms, hydrogen sulfide. It's the familiar smell in rotting eggs and so on, and in various other places. It's far more toxic than the infamous cyanide per molecule. And the other thing is it's irreversible. Once it binds to the cytochrome enzymes that are the key part of our energy metabolism in our mitochondria, the organelles inside the cell where oxygen is used, it stays. It doesn't unbind for hours. Well, many people never see those hours. A simple lungful of it will kill you with no treatment possible. And that's why workers at natural gas wells have to be very careful to wear gas masks in certain areas. Hydrogen sulfide is denser than ordinary air, so it collects down in low areas. And you don't smell it after it gets pretty intense, so very dangerous. Now, ferrous iron. Okay, I guess there is an element of toxicity here in that iron poisoning is the most common poisoning of children, certainly in the U.S. Bacteria can use ferrous iron. They can oxidize it from that ferrous state to its ferric state. Now, we need that iron in our diet, but too much causes oxidative damage to our organs. Okay, now, getting oxygen to us. It was cyanobacteria, used to be called blue-green algae, that first made oxygen available in massive quantities, basically filling the atmosphere with oxygen, well, and the oceans. So there are several twists and turns in this story for the history of life, the Earth's geochemistry, and climate. Okay, the cyanobacteria made the oxygen for the start. Okay, that wasn't good news for the anaerobes, the other bacteria. It was only bacteria then that were living and are poisoned or killed by oxygen. It did make room for all of us who are aerobes later, and take all the animals now. So, jumping to the geochemistry, if you've been to the Grand Canyon and some other sites, you can see exposed these enormous thick beds of red rock, the red beds. At the Grand Canyon, I think they're 800 feet, 240 meters thick. And there's lots of ways that can be traced to cyanobacteria making oxygen. The other thing that happened when cyanobacteria made all this oxygen available is they oxidized the iron out of the ocean. Well, there used to be a lot of iron in the ocean by various geological records. And the ocean was green, not blue. Now, the problem with oxidizing the iron to its ferric state is that readily combines with what are called hydroxyl ions, normal presence in water. Okay, but ferric hydroxide is extremely insoluble, and oceans to this day are very low in iron, which makes it pretty tricky for oceanic organisms to get enough of it. And I'll say a little bit more about that after we take a little station break here.